Hello and welcome. Today I'll be discussing the answers to the Unit 1.1, the nature of substances and chemical reactions exam style questions. The first question tells us that sodium is extracted from sodium chloride, and the overall reaction taking place is 2 sodium chlorides goes to 2 sodiums plus chlorine. When carrying out the reaction, 120 kilograms of sodium chloride was found to produce 38.05 kilograms of sodium. So we're asked to calculate the possible mass of sodium that could be produced and use this figure to calculate percent yield. So moles is mass over MR. 120 kilograms is 120,000 grams. The MR is then calculated by adding up the ARs to give 58.5 grams per mole. So then moles is 120,000 divided by 58.5 to give 2,051 moles of sodium chloride. 1-to-1 ratio between sodium and chloride and sodium. So same number of moles of sodium, then times that by 23 to get 47,173 grams of sodium, or 47.2 kilograms. And then we shove that into the percentage yield equation. 38.05 divided by 47.2 times 100 gives a 80.6% yield. The next part asks us to suggest why the yield is less than 100%. This is because the sodium chloride could have been impure. Not all the sodium chloride could have been reacted. Side reactions were taking place, and the loss of product. Suggest why this reaction must be carried out under dry conditions. This is because the sodium would react with water present. So a sample of lithium is found to contain 2 isotopes, shown here. And we're asked to calculate the relative atomic mass, the AR, of lithium, given our answer to 366. So here is the equation. We put the numbers in. And then that gives us a AR of 6.92 grams per mole. Now on to question 2. This question talks about a food company which was accused for using a banned substance in its sweets. Scientists tested 4 dyes, A through D, to find out if this was true or not. And here is the results of that. So the first question is to name the method used, and this is of course chromatography. B, dye B was found to have an RF value of 0.428. Using the following equation to calculate the distance moved by dye B. So this is a simple plug the numbers in to get the answer. So 0.428 times 7, 7 being the solvent front, which we can see using the ruler that was provided, to get the distance moved by B as 2.996 centimeters. The next part asks us to complete the diagram to show the position of dye B, which I've provided a distance for here. It would go by here, and you read across, and that goes to 3. This is because 2.996 is effectively 3 in this case. So then C, identify which dye, A through D, contains the banned substance. Give a reason for your answer. The answer is C, because the spot corresponds with that of the banned substance, or the spot at 4.6 is as it is in the banned substance, or the dye has the same RF value as the banned substance. Question 3 talks about the composition of the atmosphere, and it gives us this table to have a look at. So we need to use this table. So part A is to name 2 gases that occur as single atoms. And you could have any of these 3, argon, neon, and helium. Then next is to name 2 elements that occur as molecules. So you could have nitrogen, oxygen, ozone, or hydrogen. The next part, name the gas that has the lowest percentage. This is only one answer, which is ozone. And then part B is if the black dot represents a carbon atom, name the gases in the table that can be represented by the following diagrams. So we have a carbon surrounded by 4 other atoms. This would be methane, as that is the only one that fits that. The other one would be carbon dioxide. as that is the only other one containing carbon in the table, and also that species containing carbon only has 2 oxygen atoms. So you see information now in part 1 to draw a diagram for oxygen. So oxygen, we know, is an oxygen-oxygen double bond. Therefore, we would simply draw them next to each other. The next part talks about the atmosphere becoming polluted by substances known as chlorofluorocarbons, or CFCs. And one example is CH CIF, or as it's called, chlorofluoromethane. The first question asks us to state the number of hydrogen atoms present in chlorofluoromethane, and that's 2, we can see in the formula. And then give the total number of atoms shown in the formula. Well, we have carbon, 2 hydrogens, a chlorine and a fluorine, so that is 5. Then question 4 asks us about this diagram showing 3 methods of separation for mixtures. So what property of iron fillings allows mixtures method 1 to separate the mixture? And that is that iron fillings are insoluble in water, therefore they can be filtered. And then why can method 2 be used to separate alcohol and water? This is because alcohol and water have different boiling points. And then part 3, name the method of removing water in method 3, and this is evaporation. Next part asks us to investigate the dyes in 4 different water-soluble blue pens, 1, 2, 3, and 4. The results are shown here on this chromatography. So which 2 pens contain the same 3 dyes? And the answer is 1 and 3, as they all contain spots at 2 centimeters, 5 centimeters, and 6 centimeters. So which pen contains the most soluble dye? This is pen B, because that is the one that has the spot closest to the solvent front. Sorry, pen 2, I should have said. And then part 3 is the RF value of the substance can be used to identify that of the substance. The RF is given by this formula. So now I want you to calculate the RF value of dye A. And we can look on this. The solvent front is at 8. The dye spot is at 4. 4 over 8 is equal to 0.5. Then name the method used to separate the colored dyes. It's one I mentioned earlier, which is chromatography. Question 5 asks us about the diagrams for separating mixtures again. So a student was given a solution of sodium chloride. State which method A, B, or C he could use to obtain a pure sample of pure water from the solution. And name this method and explain how it works. So what you want to say is you want to say method A, or distillation. The water will boil or evaporate, and then the vapor will condense to give you a pure sample of water. The second part is 500 grams of solution was found to contain 43 grams of sodium chloride. Calculate the percentage of sodium chloride in the solution. So that would be 43 divided by 500 times 100% is equal to 8.6%. Question 6 then. The table shows 3 substances, their formulae and diagrams that can be used to represent them. Use the information in the table to work out the key being used to represent the different elements in the diagrams. So I'm immediately going to throw the answer up, but what you should notice is that both water and nitrogen trioxide contain this white atom, and they both share oxygens. So this, the shaded one must be nitrogen, and the black one must be hydrogen. And then if the black one is hydrogen, the middle one must be carbon. There are other ways you could do it, but that is one of them. So then you can use the same key to represent carbon dioxide. And what we want is we want a carbon with 2 oxygens coming off. And then the chemical formula of phosphoric acid is H3PO4. How many phosphorus atoms are present in phosphoric acid? The answer is 1. And then the total number of atoms in phosphoric acid, well, let's count them. We have 3 hydrogens of phosphorus and 4 oxygens. That's equal to 8 atoms in total. Question 7 asks about group 1 metals reacting with oxygen to form metal oxides. So sodium oxide contains the ions Na plus and O2 minus. So what is the correct formula of sodium oxide? That would be Na2O. And then group 1 metals react with chlorine to form metal chlorides. So give the balanced similar equation for the reaction between sodium and chlorine from this list. And we should see the answer is C. As you have two sodiums on the left side, 2 chlorines on the left side, and then 2 of each on the right side. It's the only one that balances properly. As we know, chlorine has to be Cl2. That is its natural elemental state. Next is question 8. So question 8 asks us to calculate the relative formula mass, MR, of potassium chlorate, KClO3. So we have 39, which is AR for potassium, 35.5, which is chlorine, and 3 times 16 for oxygen to give us 122.5 grams per mole. And then calculate the percentage by mass of potassium in potassium chlorate. So we would take the 39, we would divide it by 122.5, and times it all by 100 to give 31.8%. Then potassium chlorate forms potassium chloride and oxygen on heating. And we're asked to balance a similar equation that represents the reaction taking place. So looking at this, we can see that there are 2 calciums on the left side. So we need a 2 in front of the KCl. And there are 6 oxygens on the left side, and that means we need a 3 in order to get 6 oxygens on the right side. Question 9 is about an experiment to separate a mixture of ethanol and water. So what is the method used? This is distillation. The following sentences show the steps involved in the method of separation. You can have a look at them. The correct answer is CBAD. So what this would be is the mixture of water and ethanol is heated, ethanol boils and evaporates, ethanol vapor cools and condenses, and then ethanol is collected. So which letter explains why water is left in the flask? This is that the boiling point of ethanol is lower than the boiling point of water, or B. Thus the water is left in the flask, whereas the ethanol leaves or is evaporated. Then the next question, a student was investigating pigments E, F, and G present in a blue felted pen, and the results are shown here. So state what the results tell you about the blue ink. Well, it contains 2 pigments, or it contains pigment E. And then you asked to calculate the RF value of pigment F using the equation below, the same one as before. So 4.2, which is the distance moved by the pigment, divided by 5, the solvent front, is equal to 0.84. Question 10 asks us about the diagrams representing 4 substances A through E. State which diagram represents an element and give a reason for your answer. That would be D, as it only contains 1 type of atom. In the second part, state which diagram represents carbon dioxide. That is A. There's 2 carbons. 1 carbon and 2 oxygens. Give the formula of the substance represented by C. That would be C2H6 if you count them. There are 2 black spots for carbon and 6 grey ones for hydrogen. Then part B, when copper 2 sulfate reacts with sodium hydroxide, it forms copper 2 hydroxide and sodium sulfate. Write the word equation for the reaction taking place. So here it is. Copper 2 sulfate plus sodium hydroxide goes to copper 2 hydroxide plus sodium sulfate. Give the number of atoms of sulfur found in sodium sulfate. That is 1. give the total number of atoms found in formula CuOH2, and that's 5 because there's 1 copper, 2 oxygens, and 2 hydrogens, so that's equal to 5. And then iron 3 sulfate reacts with sodium hydroxide to produce iron 3 hydroxide. Write the formula of iron 3 hydroxide. So that is FeOH3. Question 11 asks us about the percentage of oxygen present in the formula of germanium oxide, GeO2. So the MR of germanium oxide is 105, adding up 1 germanium and 2 oxygens. And the percent oxygen is calculated by the oxygen over the MR of the molecule times 100 to give 30.48%. Then when germanium oxide reacts with hydrochloric acid, it produces germanium chloride and water. Balance the following equation for the reaction that takes place. So we can see 4 chlorines on the right side. That means we need 4 HCl's on the left side, and then to balance it out we need 2 waters. Next, question 12 asks us about the equation magnesium plus 2 hydrochloric acids go to magnesium chloride and hydrogen. So in the experiment, 0.445 grams of magnesium was used. Calculate the mass of hydrogen that will be produced during the reaction. So we do moles of magnesium, which is mass over AR, to give 0.0185 moles. This is a 1-to-1 ratio, so we have 0.0185 moles of hydrogen times by the MR of nitrogen, which is 2, to get 0.037 grams of hydrogen. And then it is known that 1 mole of gas has volume of 24 decimeters cubed. Use the equation to find the volume of hydrogen produced. So we need to rearrange to get the number of moles times 24 equals volume of gas. So we do 0.0185 times 24 is equal to 0.444 decimeters cubed. Finally, question 13. Oxides of nitrogen are released in vehicle exhaust fumes. They can cause smog in busy city centres as well as acid rain. 1 oxide of nitrogen contains 30.4 grams of nitrogen and 69.6 grams of oxygen. Find the simplest formula of this oxide showing your workings. So we divide both masses by their ARs. So 30.4 divided by 14 and 69.6 divided by 16 to give a ratio of 2.14 to 4.35. So we divide by each by the 2.17 to get the simplest ratio of 1 to 2. So we have NO2. Then the oxide with this simplest formula is found to have a relative molecular mass of 92. Find its molecular formula. So we add up the MR to get 46. 92 divided by 46 is equal to 2. Then we times the formula by 2 to get N2O4. Thank you for watching.